So today we're going to talk about all the components of a circle in relation to central angles and inscribed angles and their intercepted arcs. That's our goal for today. In a regular circle, we've got angles that are formed when the vertex is at the center of the circle, and those are called central angles. Okay? So this right here would be a central angle. Okay, the blue one here, because its vertex is at the center. When the angle's vertex is on the circle, we call that an inscribed circle or angle. Sorry. Okay, that's any angle whose vertex is on the circle. Okay. All right. If you're traveling around the circle and this angle is extended out to intersect the circle, the piece that it intersects, okay, this purple part here, we call that the intercepted arc. Okay, it's just a piece of a circle.
Wouldn't that just be? Oh wait, so the purple and the yellow are intersected arcs?
Yes, the purple and the yellow. Okay, the purple one is intersected by the central angle. The yellow one here is intercepted by the inscribed angle. Okay, so an arc officially is an unbroken part of a circle consisting of two endpoints and all the points in between. So it's a locus, right? It's a locus of points that begin here and then there. All right? All right. Then we've got major arcs, minor arcs, and semicircles. The minor arc is the arc that is intersected by the central angle. Okay? So this piece here is the minor arc. The major arc is the rest of the circle that's left. All right? Officially, the arc whose points are on the interior of the angle, the major arc is the points on the circle that are on the exterior of the angle. All right? And the cool thing about the minor arc is that its degree is the same, because we can measure arcs in degrees too. And so whatever the measure of this angle is the same as the measure of the arc. Because if you think about it, does that clock tell a different time than your watch? When the little hand's on the 9 in that clock, is it going to be in a different spot on your watch? Hopefully not, right? Should be about the same. Even though the watch has a much smaller circle, shouldn't the angles be smaller or something? No, it doesn't matter at all how small the circle is. Okay, this part of the circle is the same as in a bigger circle, that intersected part. The distance between 1 and 4 are going to be the same whether it's a big giant clock or a little tiny watch, right? It's going to be the same distance. And so this angle that represents the little piece here is the same as that measurement. So if this is 50 degrees, this piece, this arc, is also going to be 50 degrees. Okay? And that's for central angles. Okay? The major arc then, how do you think we'd get that? Yeah, the whole circle is 360, so it'd just be 360 minus the piece that you took out, right? So 360 minus 50 in this case would be 310, right? And that, the official words for that are right there. All right, and then a semicircle are arcs whose endpoints lie on the diameter. Makes sense, right? Semicircle, half a circle. Now, not so much on the OGT, but on the ACT Quality Core, they might ask you a question like this. A semicircle ends on points 2, 7, and 7, 19. What's the area of the circle? And you might think to yourself, what's the area of the circle? You only gave me 2 points. How would I do that?
Multiply it to get it.
Well, if all I knew was this is 7 or 2, 7, and this was 7, 19, oh, how could I, Avi? Right, exactly. He used plugged the points into the distance formula, found the whole thing, because you know that the endpoints of a semicircle end up on a diameter. Then take half of it, square it, multiply by pi, and that gives you the area of the circle. So putting all this together would be an application of that. All right. So using what we know just in general about percent, and now what we know about a circle, because all the way around here is how many degrees? 360. See if you can find the measurements of arc AB, arc HG, and arc EF. And I'll make this bigger for you if you want. Sorry. I have to say, good job, Matt. Got it. Okay. How about HG? What would that be? Rashad? Right. 3% of 360 is 10.8.
You multiply it by 360?
Right. 3%.
So 0.03 times 360.
Right.
So whatever the angle is the side too?
Yes, the angle and the arc.
Would that be?
Yeah, circles don't really have sides, but yeah, the arc. Yeah. Yep.
So we could find the perimeter by doing this?
Yep. You could also, if you actually knew what the circumference of the circle was, you could figure out exactly how long that is. We'll do that. We'll do that later, after next week. And last one, 9% is how long would the arc be for that piece of the pie? For pop music? I'm sorry? Right, 32.4. Okay? So that's central angles. Whatever the angle measurement is, the arc is the same degree. Okay? Now, for inscribed angles, okay? For inscribed angles, and if you think about it, they have a lot longer to go before they hit the side, right? So they can start out much thinner or smaller an angle than the poor guys who have to start out right in the middle and only have half the distance to
Poor guys, so they would be lucky.
to get to the sides. Okay? So so whereas, like, if this is 50, what's the measure of this arc here? 50. But would this arc also be 50? No, because it's obviously smaller for one thing, right? And it's opening up to the same amount, but it's starting way back here, so it's going to be smaller. And actually, it's half. So an inscribed angle is half the measure of its intercepted arc. You do or don't?
I don't. Oh, yeah, I do.
I'm sorry.
I kind of do.
Okay, good. All right, so if this arc were, well, let's do the angle. If this angle were 78 degrees, how long is this arc? John, any idea? Just tell me what to do. Right, 78 times 2, so 156. Okay. All right, but that's kind of basic. I don't want to insult your intelligence. So let's do this. If that's not the center. If the central angle is let's say, what does that look like? About 80. What's the measure of that angle right there? If the center angle is 80, central angle is 80, what's the measure of that inscribed angle? Well, think about, stop and reason about it for a second, and talk to your part. You can talk to your seat partner about it. Okay, so how much is the minor arc here? 80. So that means what's the measurement of the major arc? 280, right? And what do we know about inscribed angles? It's half the length of its intercepted arc. Isn't that its intercepted arc? So it's 140, right?
I got it right. Yes, it does.
Does that make sense to everybody?
Yeah.
Okay.